Hi Year 4, welcome to the next science lesson in our sound topic. I hope you've been enjoying learning all about sound so far. Today's going to be another fun lesson, but there's a warning. It's going to be very noisy. So before we start, please check with anybody you live with that it is a good time for you to do this lesson now. There will be parts of the lesson later where you'll have to make a lot of noise. So it's very important that it's okay with everybody else. So later in the lesson, we'll need to get some objects to make some noises. But first of all, let's get the short date and the title written neatly in our science books. Please, you'll need a whole new page, one new page. Pause the video and unpause when you're done. Okay, so here is what we'll need. You're going to need at least 3 or 4 different objects that can make a noise. It could be a musical instrument, it could be something that makes a noise when you shake it or hit it or play it. So there's a few ideas there and I'll show you what I've got. So I have found a packet of couscous because when I shake it, listen. I've got a hot chocolate tub because when I hit it with a wooden spoon, it's a bit like a little drum. I've also found myself a bigger drum full of almond butter, and it's just like a drum, makes a very different noise. And I found myself a metal flask which I can hit with my wooden beater as well, or wooden spoon, makes a different noise. And lastly, a frying pan that's nice and clean. That makes a lovely noise actually when you hit it. So you will need some objects, but you need to save them for later. We've got some learning to do first, and then we're going to use that learning with our objects to really make sure we're understanding different aspects of sound. So if you haven't got those bits and pieces ready, pause the video, go and get them now, and unpause please. Okay, right, we're all set. Here we go. So next of all, a quick bit of total recall to make sure we are remembering what we're learning. So please, could you do your best to remember what a digestive system is and how it works, what an insulator is, see if you can make a list of insulators, and can you recall the name of the longest river in Europe? Pause the video, have a think, even write them down. Okay, so today's learning foci are listening and absorption. I'm going to speak quite quickly today because we have a lot to cover. So let's get going. Our key vocabulary for today is pitch, volume, sound, frequency, sound wave, and maybe you can spot the new vocabulary and have a think how they might link to our sound topic. And before we travel, can you remember how sound travels? We covered it last week. There's some symbols to help you. My best tip is to pause the video and say it out loud. Even if there's nobody else there, how does sound travel? Okay, yes, of course, it travels in sound waves from a source to our eardrum. And today we're going to learn about pitch and volume. So what do you think these words mean? And could you explain the difference between the two? And if we were in school, we'd be using lollipop sticks to randomly choose somebody. So pause the video, have a good think. If someone else is near you and they're not working, try to explain what you think volume means and maybe what you think pitch means. Okay, so what I'd like you to do first of all, we'll come back to those questions, is to select one of your objects and work out how it can create a sound. So next I want you to make a quiet sound with your instrument or your object. So here's me making a quiet sound with my couscous. Okay, and then stop. Now make a loud noise with your instrument and stop. And now, what did you do differently to make a louder noise? Did you hit it harder, blow it harder, pluck it more firmly, shake it? more, what did you do? Think carefully, and if you'd like to pause the video and do the same with your other instruments, but it's not playing, we're thinking, what do you do differently to make a loud noise with an object or an instrument compared to a quiet noise? And can you explain now what you noticed with the objects? Well, sound is a form of energy, and if we put more energy into making the noise will be louder. If you watched me, and actually let's quickly do it again, a quiet noise, I don't need much energy. I'm just gently shaking it back and forwards. For a louder noise, I need more energy. And the same happens with my frying pan. For a gentle, quiet noise, not much energy. For a louder noise, more energy. And hopefully you found the same thing. So, what is the scientific word for the level of sound? Tell me now. It is volume, of course. The scientific word for the level of sound is volume. And I wonder if you can find a link between the size of your objects and the volume. Well, the size of an object vibrating will also affect the volume. So a large drum will be louder than a small drum. Now, what does pitch mean? We know what volume means. It's the level of sound. What does pitch mean? Talk to someone in the room, or have a think, or even just say it out loud to yourself. What do you think pitch means? No, not a football pitch or a hockey pitch. Pitch is how high or how low a sound is. So if I'm speaking with a high pitch, I sound like this. And if I'm speaking with a low pitch, my voice sounds like this. And this is perhaps a medium pitch. So a high sound has a high pitch and a low sound has a low pitch. Repeat that sentence in your own high pitch voice and low pitch voice, please. Excellent. The size, length and tightness of an object that is vibrating will affect the pitch of the sound it produces. Remember, any source of sound vibrates to make that sound and to pass the vibrations through the particles in the medium, which might be air or liquid or solid, and then that eventually reaches an eardrum of someone listening. Don't get confused. Pitch is very different to volume. Okay, I'm going to vary. I'm going to change my pitch now. So I'm just going to change my pitch. I'm going to go up to very, very high pitch and then down to very, very low pitch. But actually, even though I'm changing my pitch, my volume is not really changing at all. However, I can keep exactly the same pitch and I can go very loud or I can go very quiet. It's the same pitch but very different volume. So, can you now put your objects in order from lowest to highest pitch? Remember, high pitch sounds like this, low pitch is deep like this. Pause the video and try to put your objects in order. Just lay them out in front of you from lowest pitch to highest pitch. Okay, good try. So, how could we change or alter the pitch of an instrument, do you think, or an object, but particularly a musical instrument? Well, actually, what we can do, we can change the strings on a guitar or a violin and make it tighter, change the tension. You can also make the string longer, pluck it harder, and there's lots and lots of different things you can do to change the pitch of an instrument. Let's watch a little video now all about that.
On this board is a string which is fixed at one end and attached to some weights at the other. Listen to the sound the string makes when it's plucked. We can see that the string is vibrating to produce the sound. Now listen again after an extra weight is added. The string now produces a sound with a higher pitch. The weights pull the string so it becomes tighter and so vibrates faster when it's plucked. There are other ways of affecting the sound pitch of a string. These strings all have different lengths. The vibrating length of string is between the black strips of wood. The weight on each string is the same. The longer strings produce a lower pitch sound than the shorter strings. So the shorter length strings are vibrating faster than the longer lengths. All these strings are the same length and have the same weight attached. The difference this time is their thickness. The strings get thicker as we move across the board. The thinner strings produce a higher pitch sound than the thicker strings. This is because the thicker strings are heavier and don't vibrate as quickly as the thinner strings.
Okay, interesting. So let's move on. Quick recap. How does sound travel in sound waves? And do they all look the same, do you think? If we could see sound waves, do they look the same? And how do you think a sound wave might change as the pitch changes? So pause the video, have a little think, maybe a chat with people at home. Well, the pitch of a sound is due to the frequency of vibrations, which means how many times the object goes back and forth each second. So if we zoomed in on my couscous, to see the pitch of it would be how many times it vibrated in the air. If it's really, really quick, it will have a high pitch. If it's slow vibrations, it would be a low pitch. And I'm not going to read this page out for you. I think it's very handy, but I'm going to leave it there so you can pause it and have a little look to help recap what we've talked about. Okay, so here are two different sound waves. This is a low pitch. A bass guitar has big thick strings and makes a very low noise, like this. A high pitch, maybe a whistle. When I blow a whistle at playtime in the playground, the sound wave looks like this, because the wavelength is much shorter and it vibrates much quicker. So amplitude means the larger the amplitude, the louder the sound. Okay, so how tall the sound waves are, that tells us how loud the sound is. The wavelength is the gap between the waves. So the shorter the wavelength, the quicker the vibrations, the higher the pitch. Okay, you might want to pause that and have another close look at the picture. So, time for your task. Underneath your title, I'd like you to draw the table that I've drawn, nice and neatly with a ruler, please. You need two columns, one that says object and another column for sound wave. And then you're just going to do this big arrow here. You're going to write low pitch at the bottom of your page and high pitch at the top. Unpause the video when you're done, please. Okay, excellent. So now what you need to do, first thing you're going to do, you've sorted your objects into order of pitch. So the high pitch objects go at the top and the low pitch at the bottom. I haven't finished, but I've started off a very simple picture and a label. Please unpause the video when you've done that. Excellent. Okay, and task number 2 is to use the learning we've talked about amplitude and wavelength and volume, and to just have a go at drawing what sound wave you think each object makes. So the metal flask, I think, would look something like this, and the couscous packet might look something like this. Okay. So that's your main task, to complete your table, have a go with your sound waves, and as always, please take a photo and send it to your teacher so they can have a look at what you've done and what you've learned. Okay, we've already done that bit, so we'll whiz on to the plenary, which is just really a fascinating fact. Did you know humans can hear sounds produced by objects that vibrate with frequencies between about 20 and 20,000 times a second? That's what we can hear as humans. However, animals can hear sounds outside of this range. So dogs can hear a whistle with a very high frequency, so high we couldn't even hear it. That would be silent to us. And whales can even communicate with vibrations that are so low we can't even hear them, but they can. Fascinating. Lastly, Another warning, very loud sounds should be avoided. Okay, no object should be put into the ear because it can really be dangerous and even cause you to go deaf. So be careful always with sound and objects near your ears. Okay, that's the end of our science lesson. Please send through pictures of what you've done. If you also like to send a picture of you playing an instrument through to your teacher or an object, I'm sure they'd love to see it. I hope you've enjoyed the science lesson, and I'll see you next week for the next one. Take care, everyone.